So let's talk a little bit about cloud computing.
Well, I think most of the cloud discussion at the industry level pretty much been focused around the consumer space. If you think about technologies such as iCloud.
The cloud is certainly ready for prime time as far as being used by a wide variety of enterprises for real, even mission-critical applications.
Interoperability, of course, is one of the biggest issues with cloud computing, and we need those standards. I would say it's still early days. IEEE is working on a few sets of standards.
Cloud is a facilitator of big data, especially for those who aren't big enough to create their own internal clouds.
I'm expecting that standards will evolve and best practices will evolve. One imagines at some point that even this question of adherence to standards and best practices may have an effect on, for example, insurance for operational failures and things like that. If you follow best practices, your insurance costs will be less.
The world that we're going to be moving into, I would say, over the next decade or so, as I said, this is a massive transformation that we're actually embarking on. And it's going to be moving into one global seamless virtual world in terms of IP and wireless. The question becomes, how do we overcome what I call the Band-Aid solutions that we have implemented in the 20th century and not do a Band-Aid solution on the 21st century technology. And in order to do that, you need to look at this in a very bigger, higher level solution space.
In the same way that people learn to trust banks and feel reasonably secure putting their money there now, even though presumably there was the era of the bank robbers and getaway ponies or whatever. The fact is that the cloud will continue to mature, and the same way that I'd trust my money more to a bank than keeping it under my mattress, I think that it's probably better, certainly over time, to put your data that you want to secure in a dispersed infrastructure with inherent reliability and with top-notch security personnel whose job is to focus on that than to just trust yourself, certainly especially as an SMB, but even for large enterprises.
So the government can set policy for its own purposes. And in many cases, industry will not only follow that in order to serve government contracts, but it will also adopt those principles for commercial purposes as well, on the expectation that that will protect everybody, every customer, regardless of whether they're government or not. I think that we also, though, expect that private sector technical organizations, IEEE is an example, Internet Engineering Task Force is an example, and there are others, to establish standards, should be engaged, because in many cases the specialists in those institutions may bring as much or more to bear to the problems as the government can.
I think we need to really rethink, even at the university level, how many system engineers we're generating out into the field versus developers, software developers. And I think we need, I profess we need at least 10-to-1 ratio between system engineers to developers, in my opinion, in order to really solve this massive complex problem that I just alluded to in my speech between now and the year 2025. It's a long-term scenario, but that's what we have to go develop.
Security is also a concern. You know that we have a large database. We're concerned about maintaining the integrity of that database. With cloud systems, you're not quite sure where that data is stored, who's accessing that data, so you're giving up control. But in the end, I believe that cloud is a direction we have to go.
Security is, of course, a topic that always comes up in every cloud conversation. And of course, there's room for improvement in the cloud in terms of security, but there's room for improvement in everything with respect to security, and there will always be an arms race between those that would like to break in and those that would like to prevent them from doing so. So that said, I think that the cloud can uniquely perform sorted functions with respect to security. An example would be anti-distributed denial of service capabilities, where the huge network capacity of large clouds can really help to fend off denial of service attacks.
especially with respect to data, and especially with respect to data that might carry privacy information. Challenges are privacy, and of course, without security, there is no privacy.
What we don't have, though, is inter-cloud interaction. This is the place where there's work to be done, and I assume IEEE is involved in that with its cloud initiative. And that is to figure out what should clouds be able to say to each other. Not the data centers that are part of one cloud, but rather a cloud talking to another cloud. And here we have some very interesting possibilities. Rather than downloading data into a laptop and then pushing it back up again, if you need to move data from one cloud to another, and if the clouds have interconnection capacities exceeding those of a typical laptop or desktop, you should be able to say to cloud A, move this data to cloud B. Now, if the data is access controlled, for example, you also need to move the metadata from cloud A to cloud B and have some assurance it will be interpreted the same way so that access control continues to be exercised over the content. We don't have standards for that right now. In fact, we don't even have ways of uniformly representing the identity or identifier of a particular user in more than one cloud. So without getting down into too many details here, the ability to move data back and forth, to move the metadata back and forth, assure that it's interpreted correctly, is one missing piece.
All of the things that go along with data management that are non-technical, the governance of the data, how long you retain it, all of the functions of integration with other data that you might have, legacy data. Those things were not designed to be in a cloud, and therefore there is a challenge to mix what might be modern systems with the legacy set of systems.
I'm expecting that we will see a growing number of recommendations for best practices in the cloud environment with all of those issues in mind.
It's pretty clear that the cloud doesn't solve everyone's problems in the universe, and in fact that what we're going to find is a mix of legacy applications, private clouds, public clouds, and so with all that, interoperability becomes critical and standards become critical, and mechanisms for federation and identity and network connectivity to make it all work together.
For cloud to be an effective utility, top-down standards have to be developed so that I could, for instance, port my data from one cloud to another, my processing from one cloud to another, just for efficiency and effectiveness, as well as if I'm worried about redundancy and fault tolerance. I would like to have standards in that space.
So this is more like an ecosystem than it is a rigid design. It's a very loosely coupled environment, which is what gives it its vitality and its ability to evolve.